Despite the remarkable achievement of launching the James Webb Space Telescope, humanity still finds itself alone in the seemingly infinite expanse of space. No matter how many worlds we scanned, none of them showed any signs of life. They had the right conditions, but something was missing, something vital, something that we had and they didn't. What was it? And what is the hidden danger lurking in the cosmos, revealed by NASA's Chandra X-ray Observatory, that could spell doom for life on planets like Earth? Life on Earth is incredibly diverse and adaptable. It has managed to survive in extreme environments such as freezing valleys, scorching hot springs, deep-sea vents, and high-altitude ice sheets. Over billions of years, life has evolved into an incredible variety of forms, ranging from tiny microbes to large and complex organisms. Despite the vast array of habitats and incredible biodiversity on Earth, it remains the only known place in the universe where life has originated. It is unclear whether the emergence of life is common or rare in other places, with conditions similar to those on Earth. It is possible that life may originate under different circumstances than those found on Earth. The relatively short time between the end of the late heavy bombardment and the emergence of life on Earth suggests that life may arise wherever the conditions are favorable. The late heavy bombardment is a period in the history of the solar system that occurred roughly 4.1 to 3.8 billion years ago. It is believed to have been a time when the inner planets, including Earth, were bombarded with a large number of asteroids and comets. Some scientists speculate that life on Earth may have originated from extraterrestrial sources, considering the early appearance of life on the planet. For life as we currently understand it, certain conditions must be met, including the presence of biogenic elements, a source of energy, liquid water, and a stable environment that is conducive to evolution. Even extremophile bacteria, which have adapted to survive in diverse temperatures, pressures, and chemical conditions, still require organic compounds, energy, and water. Despite this, the search for extraterrestrial life has primarily focused on identifying environments with conditions similar to those found on Earth, and organisms that share similarities with life as we know it. While this approach has been fruitful in some cases, it is possible that life may exist in forms that differ significantly from what we know, and thus, we may need to expand our search beyond familiar paradigms. Our planet, Earth, possesses several unique qualities that make it an ideal host for life. Firstly, its distance from the Sun is optimal to sustain stable liquid water on a large scale throughout the planet's history. This, combined with the presence of essential chemical building blocks such as water and carbon, provides the necessary conditions for life to emerge and flourish. Moreover, the planet's chemical cycling mechanisms, facilitated by geological activity like volcanism, enable life forms to extract energy and survive. The existence of an oxygenated atmosphere, which is a result of the photosynthesis process by plant life, further supports complex life forms. Additionally, Earth's magnetic field provides protection from harmful solar radiation, making it more habitable for organisms. In the search for potentially habitable exoplanets, the starting point is to look for worlds that share similarities with our own. However, the meaning of similar varies based on several factors. One such factor is the size of the planet. Rocky planets similar in size to Earth have been detected, which is encouraging for the possibility of life. In contrast, gas giants like Jupiter seem less likely to offer habitable conditions based on observations in our own solar system. The type of star around which the planet orbits is another crucial factor to consider. The dominant force in any planetary system is its host star, and the habitable zone, the region around the star that could potentially support life-bearing planets, is dependent on the star's size and temperature. Hotter stars have wider habitable zones than smaller, cooler red dwarfs, which are the most common type in our Milky Way galaxy. Planets in the habitable zone of a red dwarf star, which is much closer to the star than Earth's distance from the Sun, are subjected to high levels of X-ray and UV radiation. Thus, scientists also consider the level of radiation the planet receives from its host star while searching for life on exoplanets. Since the first confirmation of a planet orbiting a Sun-like star in 1995, scientists have discovered over 4,000 exoplanets. NASA's Kepler Space Telescope, launched in 2009, has been responsible for more than half of these discoveries, with the goal of determining the prevalence of Earth-like planets in the Milky Way galaxy. For astronomers, discovering the first truly alien Earth has been a long-standing aspiration, and recent exoplanet discoveries have demonstrated that small, rocky planets similar to our own are plentiful in the galaxy. Astronomers have identified several exoplanets that resemble Earth in some aspects, such as size, temperature, and atmospheric composition. For instance, some of these planets are Gliese 667cc, Kepler 69c, and TRAPPIST-1e. These planets are considered potential candidates for hosting life, as they possess some of the key ingredients that are necessary for life to emerge and thrive. However, no direct evidence of living organisms has been detected on any of these worlds so far. Detecting life on exoplanets is a complex and ongoing process, and there are several factors that make it challenging. One of these factors is distance, as the vast distances between exoplanets and our solar system can make it difficult to study them in detail. Another factor is the size of the exoplanet, as smaller exoplanets may be more difficult to detect using current technology. Composition is also an important factor, as exoplanets can vary widely in their composition and may not have the necessary conditions for life to exist. Additionally, technology limitations can further complicate the search for life on exoplanets, as our ability to detect and analyze exoplanets is limited by the technology available to us. Recent studies conducted by astronomers, utilizing data from NASA's Chandra X-ray Observatory and other telescopes, have revealed a new danger that may pose a threat to life on planets similar to Earth. The threat stems from a particular phase in which the high-energy X-rays emanating from exploding stars can have a detrimental impact on planets located over 100 light-years away. This phenomenon occurs when the shock wave generated by the supernova strikes the dense gas enveloping the star, resulting in a significant emission of X-rays. The intense exposure of X-rays to an Earth-like planet may last for decades, with the possibility of triggering an extinction event. Based on the analysis of X-ray data gathered from 31 supernovae and their aftermath, mostly from NASA's Chandra X-ray Observatory, SWIFT and NuSTAR missions, as well as ESA's XMM Newton, a new study has reported the potential threat of lethal doses of radiation to planets located as far as 160 light-years away. Previously, the majority of research on the impact of supernova explosions had primarily focused on the hazards posed by two distinct periods: the intense radiation generated in the days and months immediately following the explosion, and the arrival of energetic particles hundreds to thousands of years later. However, this newly discovered threat comes in the form of a torrent of X-rays that can engulf nearby planets, causing a significant alteration in their atmospheric chemistry. For an Earth-like planet, this can potentially result in the destruction of a considerable portion of the ozone layer, which serves to safeguard life from harmful ultraviolet radiation emitted by the host star. The outcome of this could be catastrophic, leading to the extinction of a vast array of organisms, especially those at the base of the food chain, such as marine organisms. Following prolonged exposure to lethal X-rays resulting from the interaction of a supernova and ultraviolet radiation emitted by the host star of an Earth-like planet, there is a possibility of significant nitrogen dioxide production, leading to the formation of a brown haze in the atmosphere. Additionally, the damage caused to plants may lead to a degreening of land masses. Out of the 4 supernovae presented in the images, SN 2010JL has been observed to generate the highest amount of X-rays. Planets similar to Earth located within a distance of roughly 100 light-years from this supernova would have received a lethal dose of X-rays. There exists compelling evidence, including the detection of a radioactive type of iron in various locations worldwide, suggesting that supernova explosions occurred in proximity to Earth roughly between 2 to 8 million years ago. According to researchers' estimations, these supernovae were located between a distance of 65 to 500 light-years away from Earth. Currently, the Earth and the solar system are not under any immediate threat of a supernova explosion. However, numerous other planets within the Milky Way galaxy are at risk. These cataclysmic events possess an enormous amount of energy, which could significantly diminish the size of the galactic habitable zone, the region within the galaxy where environmental conditions are suitable for the existence of life as we recognize it. I hope you enjoyed this video. I would love to hear your thoughts and opinions on whether or not we will ever be able to detect life forms on exoplanets. Please feel free to leave your comments down below and let's start a conversation about this exciting topic. Thanks so much for watching.